Hey guys, here we are, gonna wrap up Chapter 18. Chapter 18, Section 7, Ozone Layer Depletion. I'm gonna talk about the ozone. By and large, the main reason for the ozone depletion, the hole in the ozone over the Antarctica, main problem, was the certain widespread use of chemicals, mainly CFCs, chlorofluorocarbons. It's kind of a whole host of chemicals that all fell under this umbrella, chlorofluorocarbons. These reduced the ozone levels in the stratosphere, which allowed more of the harmful UV radiation to reach Earth's surface. And there were actions necessary in order to try and reverse this, namely, the prevention. We had to stop producing those ozone depleting chemicals, and then the various countries involved, all of us really, had to adhere to the international treaties that banned such chemicals. You know, that's just sort of our basics of what we had to do. Now, the picture up here is a NASA picture showing ozone over Antarctic level. So the blue aspect, this thinning hole of the ozone. It's thinning over the Antarctic and to a lesser degree over the Arctic Circle. And the problem was these chlorofluorocarbons, CFCs. They are persistent chemicals. They were discovered by accident, not unusual in the realm of science, but by accident in the 1930s. They were trademarked under the term freons. They were largely used in air conditioners, as a refrigerant, in refrigerators, freezers, anything that we were trying to cool down. We put them in our aerosol cans. They were the accelerant. So if you had anything, hairspray, WD-40, spray paint, anything that you push down and stuff sprayed out, these were CFCs. Now we've largely replaced them in favor of different chemicals, but throughout the 40s, 50s, and 60s, these things were in everything, used everywhere, but they were persistent chemicals. They didn't break down. Down here on Earth, down here in the troposphere, they didn't cause problems. They didn't break down. They didn't do into anything else. They were harmless to human beings. They were inert. Breathe them in, breathe them out, really wasn't a problem. But when they made their way up into the stratosphere, this was the problem. They interacted with the UV light, and the UV caused them to break apart. And the real problem wound up being usually the chlorine. Chlorofluorocarbons in the presence of the strong UV radiation up above the stratosphere where it was being blocked by the ozone, they broke apart and the chlorines were released. The chlorine would then go on a massive ozone killing spree. What would happen is the chlorine would break off and it would bond with ozone, or more in fact, it would break it apart. And the O3 would break up into O2, and the chlorine would attach to one of the oxygens, the CO. It would then break down again, releasing CO, chlorine, oxygen, would combine with another ozone molecule, breaking down again, releasing, causing two O2 molecules, releasing the chlorine to go out again. And a chlorine would go along and just destroy hundreds of ozone molecules until the winter time came, and then the chlorine would get frozen into the polar stratospheric clouds. So the hole over the Arctic was occurring in the spring and summer when these clouds dissipated and the chlorine got freed up. So during the spring and summer, the hole would grow. During the winter time, it would shrink back. But it was these chlorines and the CFCs that were causing the destruction, and they were destroying ozone faster than ozone could be created, leading to this thinning, this hole over Antarctica and also over the Arctic. Well, why does the ozone depletion matter? Why do we care, right? It's over the Antarctic or over the Arctic Circle. Well, it's because the ozone protects the Earth's surface from the damaging UV radiation. And as the ozone would deplete, well, these clouds would carry it out, and we would have thinner areas over, specifically areas of Canada into the US, down in the south over Australia into South America, causing problems. And what are these effects? I'm throwing a kind of big chart up here. I'm just going to run through it real quickly. Well, with human health, it caused worse sunburns. Exposure to UV is also what caused premature aging of the skin. Also, the UV ray damages your eyes. It causes cataracts to develop much quicker and or worse. Also, any kind of skin cancers. Once again, UV radiation in the skin weakens the skin and also cause mutations. Immune systems get suppressed by it. When we go into food and forest, well, excess UV can also damage the photosynthesis process. The photosynthesis is the bottom of our food chain. Also, when we talk about getting into the ocean, it begins reducing the phytoplankton. Now, especially up over the Arctic and the Antarctic, phytoplankton is the base of the food chain, and it's where all the nutrients are actually coming from. The phytoplankton releasing, then the zooplankton don't have food, if you don't have, anyway, the whole disruption of the food chain takes place. It also decreases the productivity in our forests. Get up far north, this is the taiga area, and a lot of areas were getting disrupted from it. Wildlife, certain species, it's causing skin problems for them. Amphibians, we've seen a great loss of amphibians, part of it, and also cataracts and other organisms with eyes similar to human beings. Most mammals have eyes, and they're sensitive to the UV radiation in the same way. And then with air pollution and climate change, it increased the acid deposition, acid rain, if you will. Photochemical smog, this is from ozone. Extra UV coming through the emissions creates ozone in the troposphere. This leads to greater amounts of smog. And then while in the troposphere, these CFCs also act as a greenhouse gas. So the ozone depletion is a big deal, but even the CFCs were greenhouse gases while they were in the troposphere. So this comes down to one of the major successes of environmental science, reversing the stratospheric ozone depletion. Mainly, we had to go to prevention. We stopped producing the ozone depleting chemicals. Now, they have been banned. Almost nobody uses them anymore. There's very tiny examples of it. It's still going to take till 2050 to get back to 1980 levels because they're persistent chemicals. We've stopped using them. It's been well over 20 years. We've reduced their impact. It's been well over 20 years since we've stopped using them, but it's going to be another 30 before we're back to our 1980s levels. It's healing. It's getting better. We're letting nature take its course, and it's coming back into control. It's just going to take time. Now, the agreements that led to this, number one was the Montreal Protocol. This cut the emissions of CFCs. Also, there were very few large corporate organizations that were manufacturing the CFCs. This cut through a lot of red tape of people trying to lobby against it. It was very few companies that owned the rights to make it, and they were able to make other chemicals to replace the CFCs. So since it was a handful of companies that were responsible, those handful of companies were willing to get on board and cut it because it was best for the environment. Later, we've had the Copenhagen Agreement, and this has accelerated the phase out of CFCs and either some other chemicals that also lead to the ozone depletion. It's not only CFCs, there are a few others, some hydrobromides, some hydrochlorofluorocarbons, bromides, several different categories, but the Copenhagen Agreement is cutting back on all of them. Guys, this takes us to some of our big ideas and just tying the chapter together. With air pollution, we have some serious global problems. We talked about outdoor air pollution. Mainly this is coming to the burning of fossil fuels, the industrial smog, photochemical smog, and acid deposition, acid rain from putting primarily sulfur dioxides and the nitric oxides in the atmosphere. We have indoor air pollution with the various chemicals that we wind up releasing in homes, whether it's VOCs, vapors of certain kinds, radon gas, all kinds. But every year about 7 million people die prematurely because of air pollution. About half of these are coming from the less developed countries. And we need to give top priority to preventing outdoor air pollution and indoor air pollution and do everything we can to reduce the stratospheric ozone depletion. Guys, this pretty much ties everything up together, but what it comes down to are grassroots movements. What led to the Clean Air Act originally was you and me going to the government and complaining and demanding action be taken. This is what we have to continue to do. We have to reduce our pollutants by relying more on direct and indirect forms of solar energy. We need to go to clean and renewable energy sources. We need to recycle and reuse as much, if not more, than what we use. And we need to use locally available renewable energy sources. Solar panels up on our homes, wind farms nearby whenever possible. Guys, this is the route to go. Take care. We will see you next time. And that wraps it up for Chapter 18.